So I'm going to try to do a review of implicit differentiation. So I'll be using the notes that you had in class. Hopefully this will help out to fill out any gaps that you might have. Implicit differentiation, it's a way to find derivatives when y is not solved for. So what do I mean by that? If you had a function like x equals cosine of y is not by itself x's, so you would have to use implicit for that one. If you had something like x squared minus 2xy plus y squared equals 5, you'd have to use implicit for that. But if you have what we are most probably used to, something like y equals and everything is in terms of x, then you would not need to use implicit differentiation for that. And the other thing you want to remember is that the derivative with respect to x of the function y is dy dx. The derivative with respect to x of the function x is actually just 1. And the real reason why is because you would have a dx over dx in the back, and that cancels, leaving us just with 1. dy dx does not cancel. So those are two facts that we'll have to use throughout most of the problems. So here's a problem that we did in class. Find the equations of the line's tangent and normal to the curve. I'm going to rewrite this function. And I'm choosing to rewrite it this way because of the fact that I see too many people get the problem wrong otherwise. When you find derivatives, no matter what type of derivative you're doing, when you have an equation, you're going straight through and finding the derivative of each term. So the derivative of this would be 2x. The problem with this is the product rule. So I'll do this part in pink. Product rule says, first, leave the first term the way you see it, multiplied by the derivative of the second, well, the derivative of y with respect to x is dy dx. Leave the second term, multiplied by the derivative of the first. The derivative of negative x would be negative 1. And now we are back to the third term, which is 2y is the derivative multiplied by dy dx. Anytime you take the derivative of a term that is not the same as the respect to variable, you'll have this differential show up. And then in the back, the derivative of 7 is 0. So we will keep all the terms that have a dy dx on one side. We will move all terms that do not have a dy dx to the other side. And so we get positive y, and then minus the 2x. What I moved were these two terms. And then our last step, second to last, factor out the dy dx, because it's a common factor, and then divide out to get dy dx by itself. So we get y minus 2x divided by negative x plus 2y. So that is our derivative. Now what they're asking you to do is find the derivative at a point, because we want to find the equation of a tangent line. So the derivative at negative 1 comma 2 would be, substitute in all your values. Y is 2, x is negative 1, x is negative 1, and y is 2. And we get left with, on top, 2 plus 2 makes 4. On bottom, we get left with 1 plus 4 makes 5. So that is the derivative. Therefore, using what we just found, the equation of the tangent line would look like y minus 2 equals 4/5 times x minus 1, negative 1, so it turns into a plus. And then tangent normal looks almost exactly the same, but now I do the opposite reciprocal for the slope. And there you have it, your tangent and normal lines. What I am going to do is actually use the derivative that we have right here, and I'm going to need it for the next problem, which I had you find exactly the same using this same equation, I'm asking you to find if they're a horizontal tangent line. And we have to find the horizontal tangent lines. Well, given this phrase, we know that that's where we take the derivative and set it equal to 0. So we have our derivative, which is y minus 2x over negative x plus 2y. And we want to set that equal to 0. We're going to multiply both sides by the denominator to move the denominator. And this denominator cancels. We are left with y minus 2x is actually equal to 0. So we get y equals 2x. You have two variables, and you can't solve. So what we're going to do is substitute back into the original equation, which is x squared minus xy plus y squared equals 7. Wherever I see the variable y, I'm going to replace it with the 2x. So you are left with x squared minus x times 2x plus 2x whole thing squared equals 7. We get x squared minus 2x squared plus 4x squared equals 7. And we get 5, so 3x squared equals 7. Therefore, x equals plus or minus the square root of 7/3. On top of that, we get that y, so actually let me go back over this way and get the 2 points. We have positive root of 7/3. And how am I getting the y variable? Substituting x back into here. And then we also get that the negative root of 7/3 comma negative 2 root of 7/3. Now, they actually both are not answers. One of them works and one of them doesn't. Now, sometimes both might work. Sometimes only one of them works, but you actually have to figure out which one is the actual answer. And so we're left with something called an extraneous root. So what I'm going to do is come over here to a new page just to go through the extraneous root. Let's see. Paste this guy in. So we have our answers, and then our original equation was, let me put that to the left. Oopsie, sorry. Our original equation looks like it was x squared minus, let's take this over too actually. Alright, so here we go. We're going to substitute both back in. So we get x squared, so let's use